Alright, in this section here we're going to be talking about inverse functions. And so we're going to revisit a topic that was discussed earlier, and that was about relations and functions. And that's what we're going to talk about first. So remember, a relation, which I'm just going to label a relation as R. Okay? And a relation is a set of ordered pairs. Alright, so here's an example. For example, I'm going to give a set of ordered pairs here, 0, 1, 1, 2, 2, 3, and the list goes on. So maybe you can kind of see the pattern here. I think it's pretty easy to see. So this is known as a relation. It's just a set of ordered pairs. And remember, there was a special kind of relation that we called a function. And that relation, if all our first coordinates are all different, okay, that relation is known as a function. So all the first coordinates must be unique. Alright. Now the inverse of this relation, and we're going to label that as R with a little -1 up here. So this is going to be considered the inverse. And all the inverse is we're going to flip both these guys here. We're going to exchange them. So 1 goes there and 0 goes there. Alright, and 2, 1, and 3, 2. Dot, 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 going on forever. Okay, so this relation is the inverse of our original relation. And all that means is we're flipping these numbers right here. The first and second coordinates, we're just exchanging them. Okay? Alright, that's all that means. Now, on a more general note, we would say that, for example, we might label R. Now, this is just generally speaking here. So this would be X and this would be Y. Okay, and in this particular case right here, we've got y is equal to x plus 1. So this piece here is really defining our relation. Okay, and then I'm saying that x is an element of n. Now remember what n is. N is the set of natural numbers. Okay, so we're just working with discrete points here. Alright, so in other words, when I plugged 0 in for x right here, we got y became 1, right? Plug 0 in, therefore y is equal to 0 plus 1 is just 1, right? And then we went and plugged 1 in, and then y is 2. See that? And so forth. Well, this particular relation here is a function, okay? This relation is a function, alright? Now what we want to do is we want to be able to find our inverse by looking at this guy right here. So we're going to be given this, and we want to be able to come up with another function down here, right, that describes when I plug 1 in, I get 0 out. When I plug 2 in, I get 1 out. When I plug 3 in, I get 2 out. And so that's really what this discussion is about. And that is how, once we're given our function, how do we find the inverse? And so remember, what happened here is we flipped these guys. Okay, and I'm going to write this out more generally. So our inverse is equal to, we switched these guys around, y and x, right? We switched them around. Okay, and that our ordered pairs was x, y, and I guess I should say actually, or I can just go ahead and say this, our ordered pairs came from R. Okay, R being the relation, not real numbers. This is, R doesn't stand for real numbers here, this stands for relation. Okay, in other words, this set right here. Okay, so x and y comes from this set, and all that we're doing is flipping the first and second coordinates around. That's all we're doing. So you see, that's what we do. Okay. All right. So let's expand on this a little bit. Now remember, I'll draw a line here. We had y is equal to x plus 1. So this is what we're working with. Now I want to mention something about this set of numbers that we plug in for x right here. So the set of numbers was n, where we're using up here the natural numbers. And so in other words, I plug 1 in, and actually, did I make a mistake? I think, okay, I started with 0 here. If we're using the set of natural numbers, okay, remember the set of natural numbers is 1 through 1, right, to infinity, or 1 to n. We have to start with 1 here, not 0, okay. Unless we're defining it to be the whole numbers, then we would start with 0. But this set right here, 1, 2, 3, 4, and so on, this is known as the domain. Okay, so this set is the domain, and then this set over here, which was our output, so when we plugged 1 into here, this, we got 2 out. We plugged 2 in, we got 3 out. When we plugged 3 in, we got 4 out. When we plugged 4 in, we got 5 out, and you can go on with this. Alright, this is known as the range. This is known as the range. And so remember, we can write this as an ordered pair, 1, 2, okay, and so forth. 2, 3, alright. But now, you know, this section's about the inverse function, right? So the inverse of this, when we plug 2 in, we get 1 out, right? Remember, it gets flipped around here. So remember, this is x, y, and this down here becomes yx, okay? So when we flip 2, when we plug 2 into the inverse, we get 1 out. When we plug 3 in, we get 2 out. So you can see, you can just trace this right on back into this direction right here. Okay. Let's say I had something that looked like this. And we had 1, 2, 3, 4, just some numbers here. And we had some guys over here. And this guy gets sent to this point. Okay, and when we plug 3 in, it also gets sent back to that point. Now if this is our function f, right, what about our inverse function? The inverse. Well, if we're at this point, which one of these are we going to use? Are we going to use this one, or are we going to use this one? Well, basically what this means is that this function here does not have an inverse. Alright, it does not have an inverse for this set, for this domain right here. Okay, this does not have, so no inverse. Because you can't have a point and then get traced back to 2 different places, because that would be not a function, remember? That would be not a function. Okay, for something in your domain to get mapped back to 2 things in your range, that's not a function. Alright. So this is to kind of look at it, drawing a picture here of what we're talking about when we talk about domain and range. Now let's just go ahead, since all that's been taken care of, let's go ahead and work. Let me give you some problems here. For example, f of x is equal to 3x plus 1, and we want to find f inverse. Okay, we want to find the inverse of f. Okay, Okay, so this is what we're going to do. I'm going to go ahead and use drop this f of x here and just write y. Okay, so this is what we're given, and we want to find its inverse. Well, here's the technique that we want to use. We're going to flip the y and the x here. We're going to exchange them. Put the y here and the x here. Okay? And then all we're going to do now is we're going to solve for y in this equation. And that means that I'm going to take this 1 over to the other side. And then I'm going to multiply both sides by 1/3. So this is going to be the technique that you use to finding the inverse. And so we have y is equal to, now I'm going to write it like this. It doesn't matter how you write this, but I'll just write it like that right there. Okay? And so we have y is equal to x minus 1 over 3. And you know, usually the most appropriate thing is to write the dependent variable on the left, x minus 1 over 3. Alright, now let's actually look at a pattern here real quick. I am going to write this differently because I just thought of something. I'm going to go ahead and write this as 1/3 x minus 1/3. Now you notice the slope of our line here. The slope is m, so remember we defined m to be the slope is 1/3. And let's go back up here and look at this. So we're just identifying a pattern. And you notice the slope here is 3. Okay? So in our inverse function, the slope is the reciprocal of the slope of our original. Alright, so let's keep that in mind, because that could, I don't know, could help us out at some point in time. But what I'm going to do now is I'm going to go ahead and graph both of these so we can kind of look at what the graph looks like. So we're going to graph the original up here, and then we're going to graph the inverse. And we said that the inverse was 1/3 x minus 1/3. So let's graph both of these and take a look at the graph. Okay, so here's the graph of our two functions that we just graphed. I don't know what that is. Oh, these are places, I guess, where it crosses the x-axis right here, I suppose. Anyway, if you notice, remember when we plugged 0 in, we got 1 out. So in the inverse, if we plug 1 in, we get 0 out. So you see that? Okay. So let's see, this line here is the 3x plus 1. Okay, this is the 3x plus 1. And this graph here is the 1/3 x minus 1/3. Alright, and you can always tell if these two are inverses if you just graphed y is equal to x. Now I'm going to do that. I'm going to graph y is equal to x. Okay, so the green line here is y is equal to x. Now, if you notice, this side is a mirror image of this side here. So if you could pretend this is an edge of a mirror, you know, you would see this would be, they'd both be a mirror image of each other. Okay, so that's one way to look at this. And now I'm going to show you a way to test if two functions are inverses of each other using what's known as the composition of function. Okay, the composition of function. If you looked at this here, when we take 4 and we plug it into the function, we get 1 out, right? So that means that if we take 1 and plug it into the function, let's see, yeah, we get 4 out, which is right here. Okay, so that was that x comma y, right, and y comma x. They're both inverses of each other, remember? Okay, alright. Okay, so this is how we're going to test if they're both inverses each other. F of f inverse of x, do you see this, is equal to, Alright, this is known as composition of function. Okay, and I'm not sure I've even discussed this in any of the previous sections, but I guess you're going to get a crash course on it right now. So we're going to test if this f of x is really the inverse of f inverse of x, or vice versa. And this is the way to test it. So what we're going to do is I'm going to take f inverse of x, that would be this whole thing right here, and I'm going to plug it right on in for this x. Okay, and so we're going to end up having f of f inverse of x is equal to 3 times, now I'm going to take this whole piece right here and just substitute it right in for this x. You see that? So we're going to have 1/3 x minus 1/3, alright, and then plus 1. So this whole piece right here got, they took this x out and put this whole piece in right here at the inverse. And then what we're going to do is just simplify that down. And so I'm going to distribute this 3 across, so this becomes x minus 1, and then we have this plus 1 over here. And it looks like it's all going to cancel down to just x. Alright, so that works out. Now we need to try this over here. Let's do that one. And so we're going to have f inverse of f of x. So we're going to take 1/3, and now you see this x right here, the 3x plus 1 is going to go in replace of it. And then we have, where are we at, minus 1/3. I confused myself because we're looking at that. But anyway, so the 3x plus 1 got substituted in for just the x, and now we want to simplify that down. And we distribute this 1/3 across, and so we have x plus 1/3 minus 1/3, and I'm not going to rewrite that. And so that looks like that all condenses down to x also. So as you can see, they both condense down just to x, and that means that these two functions here are inverses of each other. Okay, or inverses of each other. Alright, so if you're given two functions and you want to find if they're inverses of each other, this is the way to do it right here. Composition of function. Alright, well, let's work another example on how to find the inverse. Alright, and let's try to center our screen here. Okay, so let's try this one here. We have f of x is equal to x cubed minus 4. Alright, x cubed minus 4. So I'm going to rewrite this as y is equal to x cubed minus 4. And then remember, we want to switch these guys around. And now we want to solve for y in this problem here. So I'm going to take this x, bring the 4 over. And now to get rid of this cube up here, I'm going to raise both sides to the 1/3 power. Right? And 3 times 1/3 is just 1. And you know what? I'm just going to write it over here, and I'm going to flip this guy around. So don't get too confused there. So there you go. This is going to be the inverse function of our original up here. And so f inverse of x is x plus 4 raised to the 1/3. Now let's graph those and see what we got. Alright, so this is the line y is equal to x. Alright, and this line right here is the x cubed minus 4, and then this line right here is going to be the x plus 4 raised to the 1/3 power. So look at this bilateral symmetry that we have here. Alright, so we can tell just by looking at the graph that Alright, we're going to test if these are both inverses of each other once again. So I want to go through and show you how to do this again, give another example. So we're going to take this whole piece here and we're going to plug it right in for x right there. So we have x plus 4 raised to the third, and of course this whole piece here is raised to the third, 1/3. X plus 4 to the 1/3 all raised to the third. Okay, minus 4, and then we want to simplify this stuff down. So we multiply exponents, so 1/3 times 3 is 1, so we're just left with x plus 4. And then minus 4, and as you can see, that's all going to reduce down to x. Alright, so looking good so far. Now what we're going to want to do is do f inverse of f of x. And that means we're going to take this whole piece now and plug it into this x right here. Alright, so we're going to have x cubed minus 4, alright, and then plus 4, and the whole thing raised to 1/3. Alright, and then we want to simplify that all down, so this is negative 4 plus 4, right, that's going to cancel out to 0, and we're left with, and of course that now 3 times 1/3 is 1, so we're left with x. So there you go, they're both equal to x, and therefore they're both inverse of each other. Alright, inverse functions of each other. Anyway, I've given some examples here of how to find the inverse and how to check if two functions are inverse functions of each other. And I'll be adding more to this later on in the year at some point in time, but at least you get the basic idea of what an inverse function is.